Hello, everyone. Thank you for joining today's webinar. So today we are discussing how to build a ChatGPT app on your own data. I am Shweta Agarwal. I am leading the marketing for Asia Pacific and Japan region for Single Store. And I warmly welcome you today to our webinar session. This is going to be very, very exciting for all of us. So let me start with sharing my screen. So today, as you know, you all are here to listen to our exclusive APAC edition of how to build a ChatGPT app on your own data. Let me begin by giving you some logistical reminders. Today's session is being recorded and you're currently in a listen-only mode. You can submit your questions through our question and answer panel at the bottom that will be accessible to all the participants. We have fantastic technical experts with us. So our technical experts include our Chief Marketing Officer, Madhukar Kumar, Arnav Komet. Arnav is our Product Management Director. Rakesh Puttaswamy, who's our Senior Solutions Architect, who will be responsible for answering questions live to you, and also Mike Newman, who's our Enterprise Solutions Engineer. He will be interacting live with you in the live question answer. We have a fantastic lineup of the speakers. Along with that, let me give you a brief introduction of Madhukar and Arnav, who are presenting this session. So Madhukar is our Chief Marketing Officer, and he has a deep technical knowledge in the data engineering space. Madhukar has been in this space for quite some time now, and he has a background in software engineering and recently has also led product marketing and product management teams in the cloud data industry. And Arnav is a seasoned product leader in the data and AI with experience in companies such as Single Store, Microsoft, and Splunk. A quick note on the agenda today. So today we are going to enter into the wild world of ChatGPT. We're going to understand how you can build your own ChatGPT application based, especially tailored to your own data. Today, we'll be giving a quick overview of not only a ChatGPT app, but also on its upcoming phases and how it impacts the industry. Then we will introduce an awesome new Squirrel bot application, which is built on custom data by Single Store on ChatGPT, using ChatGPT. Then we will introduce an intelligent application and how do you build an intelligent application yourself in just a few hours. And we will be also covering some of the best practices and considerations for GPT in terms of apps and database development. Finally, we would love for you to follow along today's session, and we have an awesome surprise for you guys. So if you follow along today's session, today's demo and tutorial, in fact, you can sign up just now for Single Store's free trial. You can go to this bit.ly link. It's called bit.ly /APAC-ChatGPT-raffle. And if you're able to sign up and provision the S00 workspace, you can actually win Apple AirPods Pro. So that's today's raffle. And just visit this link and we'll announce the winner at the end of the webinar today. Just go to this link. And if you're facing any issues with the link, I'll also paste it in the chat section just a few minutes so that you can access the link directly. Now let me move on and give the handle to Madhukar. So Madhukar will take you through the ChatGPT webinar session, and he will take you through the entire presentation on how to build your own data. And post Madhukar session, Arnav will be taking care of building the application from the scratch. Over to you, Madhukar.
I'm assuming everybody can hear me and see my screen properly, and really excited about this because, as Matt said, I started off my career as a developer And to me, I think what we're going through right now is one of the most exciting times you can ever be living through when it comes to somebody who is, I consider myself more of a mechanic versus an engineer that can assemble parts. So we will be using single store today. And if you haven't already, I would suggest go sign up for it. I'll show you very quickly how to do that. But it takes literally like 30 seconds, and then you can follow along. You can also download the code that we will be going through, that Arno will be going through today. All right. So, in case you haven't heard, there's this new thing called ChatGPT, which came out in November. And the reason why I think it's huge, or we all know it is huge, is because my daughter who is in school, she knew about it about a couple of weeks later. And my parents, who are in their 70s and 80s, they knew about it a month later. So obviously everybody started using it. And what's been on everybody's mind is, what is the next evolution for it? Like, where is this going to go? And we've been keeping a close eye. I've been playing around with it. Arno have been playing around with it. Our engineers have been playing around with it. And what we realized is a lot of customers, and even us, they're looking to say, ChatGPT is good, but it is trained on data which was available on the internet till 2021. So if you ask ChatGPT today, something that came out on the internet, let's say a few months ago, and I'll use the example of LangChain, and you can do this while we're talking, ChatGPT would not know. The second thing is, if I ask ChatGPT to say, hey, tell me how many documents were shared with me on my Google Drive in the last 2 weeks, it would not know that either, because it doesn't have access to my data, which is behind the quote unquote firewall. So what we started to look at was, we said, this is great, but what if we actually created an application where ChatGPT in some way had access to all the data for a company? And that data could be your Slack conversation, it could be a support tickets, it could be a code, it could be a documentation, things that are not generally available to ChatGPT. And while we started to work on that, I just for fun, I asked ChatGPT, it said, hey, tell me, what is your next stage? And of course it said, being context aware and customization, those two things jumped up. But more recently, what we saw, or what I started to see, is that now people are not just creating applications that are context aware. Context aware means I have access to my data, which is behind a firewall, and data aware, which is all the data that the company has behind the firewall, so to speak. But it's also now agentic. So if you heard of LangChain, what LangChain basically does is it has access to all the different models. It's a Python library. It has access to your data, so it can provide better prompt to ChatGPT or OpenAI, or it could be other models as well, like Hugging Face, DALL-E, and so on. But what it can also do is can perform actions. So that is agentic. And so now we can create an application which basically is a nested, think of it as a function that takes the user input, does a semantic search with your data, finds matching stuff, generates a prompt, sends it over to OpenAI, gets the response back, and the next step is it takes the action. So that action could be go send an email, you go post in Slack, go, if I'm creating an application, go install applicant node on my computer and then go create this thing or directory. Of course, it needs to have access to my file system, all that. But now you can go one step further. So if you combine the two, it's where we think the world is headed in terms of application development. But the thing that's most important is the context and data aware piece. So if I were to try and build an application today from a data perspective, there are two things I can do to make any model, any LLM, specifically OpenAI, be aware of my data. One is I can download their older version of the LLM, which is ChatGPT 3 and I think 2.5. It's open source. You download it, then you train it against your own data, but you need to have a bunch of resources. You need to also have things like, training your GPU, and after, having a big, very well experienced team, you might have a good model that works against your data. But the second thing, which is far easier, and I would say a path of least resistance, is you contextualize the prompt. You take the data that your users are giving you in your enterprise application, but you do a match with the data that already exists, and you do that quote unquote locally behind the firewall. And so for there are a couple of things that now jumps up. One, you have to have semantic search, and two, you could also combine it with keyword search. So you need data that is there and it's vectorized, because you want to do semantic search. So you have to vectorize that data. So you can do matches in a few milliseconds, not in few seconds, because you're now going to interact with ChatGPT. And it should have all the data that is currently sitting in your transaction database, but maybe also from your analytics database, and can do joins as well. And secondly, if you are, let's say, in retail and your data is coming in real time, you want that to be streamed into this exact same vector database where you can run queries in real time as well. So what we did was we took the second piece and we created our own application. We are calling it SquirrelBot, or SQL with an R in it. And so let's take a look at what SquirrelBot is and what you can do with it, because with this, we will now show you how to create your own bot. So let's take a quick look at this one.
Start building, pick my database. No connection string? Even better. Ask Squirrel? All right, let's see what you can do. Help me sort and organize these customer reviews. Well, how about it? I'll take that. Nice, we're on a roll. Okay, what about the data I already have? Wow, this keeps getting better. All right, now for the real good stuff. Full text search. Optimize my table? You got it. And that's a wrap.
All right. So what I wanted to do next is just quickly show you what this SquirrelBot is and where you can access it and how you can utilize it. So if I just click on this link, which is the SquirrelBot, you can go to singlestore.com and just do /SQRL, or you would see a banner there that will show up here. And you can ask in plain English, create a database schema and things like that. But I'm going to go one step further. I'll sign in as myself into our cloud instance. And here in my cloud instance, you already see that there are certain prompts that has been pre-created for me. If I just click on that, what it's doing is, as you can see, it's only looking at our data. So single store documentation, it's looking at code, our own repo and all of that, which we have vectorized. We have put it in our instance of single store that OpenAI doesn't have access to. It does a semantic search. And then when needed, it will go back and, after it's done the match, it will go back and then make a call to OpenAI and get back the data. One other thing, which what Arno is going to talk about as well, is we have created this notion called notebooks, which if you have ever used Jupyter or if you have ever used Google Colab, it is identical, where you can now have Python code as well as SQL all combined together. And I'll let Arno go through what it looks like. but you can build an end-to-end application now. And while you're building it, you can ask SquirrelBot to generate the SQL for you. And while it's generating, you just copy and paste it over here. And that's kind of what we do today in terms of building this new application that we are looking at. Yeah, and again, Arno is going to go through this. So let's go back to what we are talking about here. So how does this app or these apps typically work? Now, keep in mind, the SquirrelBot that we created is not agentic in the sense it will not perform the actions for you. But if you use something like a LangChain, it could do that as well. And if you use a notebook which has Python code and has access to your local file system and other stuff, then you should be able to do that too. But first, the user basically now sends, a general query, and that query, before it even goes anywhere else, we take that query, send it over to our database, which is a single store database. And here we have vectorized all the data. In this case, it's going to be a movies database that Arno is going to talk about. Then what it does is this database also has pipelines where data from other data sources are coming in, including it could be a CSV file that's sitting or gets repopulated on your S3. It could be your other databases like Snowflake or other stuff, and could be other data sources too. This is happening in real time. You're converting this into vector. Now you do this matches. It comes back to your application. Then you do something with it, send another prompt to OpenAI. OpenAI gives a response back. And one quick thing I will say is that OpenAI, when you send it APIs as of March 1st, it doesn't store it. So any data that you're sending over APIs is actually not stored unless you specifically ask it to. And then finally, when it gets back the response, you may want to tweak it. You may want to check for accuracies and other stuff. Then you send it back to your enterprise users. So a couple of other things to note is using this, we are also making it very specific to single store. So for example, if you go to SquirrelBot and say, hey, tell me what the weather is in Portugal, it will tell you that it cannot give you that information because it's more trained towards doing a specific task or specific goal. And I think that's the next evolution. That's where it's headed. So enough talk. What I'm going to do now is to hand it over to our experts, Arno, who's our product manager, to show you how to build a ChatGPT app with Squirrel, which is a ChatGPT app. So it's kind of like Inception. So let's take a look at that. I'm going to stop sharing and I'll let Arno take over. Arno, all yours.
Hello. I hope you hear me. Let me
share. I can hear you.
Okay, perfect. And you see my screen? Okay. To give you some context, Pranav and I are very like citizen app developers. So, we are product manager, but we wanted to build an application showing how easy it is to marry search, like traditional search, semantic search, and analytics together. And we wanted to host it in an application like Vercel. And so we created that application using the full movie lens, 25 million data sets, but it really has 65,000 rows. And like we collaborate through our single store notebook. And for this demo, like we created like this webinar, we created notebooks that you should be able to run through here by going on the movie recommendation. So then it can be you can follow the flow as I talk through how we build it on the prototype side. And finally, we host it on Vercel, so you can see the app here. Host it on Vercel, and let me ask like some question. So this app is very simple. It's like a prompt, and essentially as I type, I like Pirates of the Silicon Valley, for example. Like antitrust, because I was at Microsoft in 2001, and The Social Network. That's my favorite movie, so I'm picking my favorite movies. We need at least to be 3, and then we send a recommendation, and that takes both like the provide like a matching. That's like the semantic search, but also add additional information that you can use for filtering. Like here, it's an example of average user rating. So I only want to see movies that are above 3, for example. So that's the type of application we build, and we will go through the flow on how to get things working on a notebook. So I presented that application. There are like 5 steps, and like the first steps here is to use to do the data ingestion, and I use Squirrel for that, although like to ingest the data. Then you have data preparation, table preparation, and data vectorization. You could use ADA or sentence transformer. In this notebook, we are installing sentence transformer. It takes around 2 minutes to install, so I hope you install that before. And then you have like the prototype. Notebooks are great at prototype, code, and queries, and collaborate between Pranav and I. Then comes the fourth, like the outside single store, is building the front end in VS Code. So we use Flask with Python and HTML, index HTML file, and really we use OpenAI there at this point. And frankly, we didn't need any bots to help us deploy that on Vercel by just having GitHub, because that's pretty simple and straightforward. So let me start on this data ingestion and go through the journey. So now you should start the notebook. You see on the data ingestion, we asked Squirrel, and we asked Squirrel that we needed 3 CSV files to get into single store movie tags, and we needed to run full text search on title to help find the title. So you see, Squirrel gave like multiple steps. I added the one. It's not Squirrel there. So I'll create the table first, then create the pipeline. You see, it doesn't know like the context of the data, and that's something that we will add into Squirrel, that you can use metadata context, but it didn't know, so it won't be able to map exactly all the fields. But it helped me get to 80% there on the result. So that's the pipeline. Then start pipeline, then create a full text index on movies title. And finally, it gives me a way to how to use search, like match title against. So it gave me a code snippet there. If you look at the notebook, if you start the notebook here, and I'm going to drop the data, you will see that's slightly different. I needed to ignore one line because there is a header. No database selected. So yeah, I need to use, that's the database selected here. So in notebooks, you need to just use %SQL, and you select the database, and essentially we do a native integration into single store. And so that's the 3 pipelines that to ingest the data. So that's the 3 pipelines we created there to ingest the data. Once the data is ingested, there is a small data preparation. It's really like this movie recommender has a bunch of tags, but all tags are per movie, per user ID. So what we needed is doing a concatenation of all the tags into the movie table. So we created a new movie with tag table, because that tags are going to be very important in similar semantic search, not just using title or genre. So we put that tag. Some have more than 1,000 movies have more than 1,000 tags, so it's very rich. And that's the table that we have here. If I switch back, I want to make sure we have all rows, 25 million, so it's a relatively small data set. And we do the concatenate, like this new table with tags. So that's it. We have now done the data preparation, and it's now phase 2. sorry, we were on phase 2, but that's the next phase 2 in the phase 2 or step 2, which is about the vectorizing data. You see here, I'm taking, like, you can follow on the notebooks, it's exactly the same code, the SQL result. So essentially, I'm using again SQL and say, hey, use this output result from that query. So that's very practical and simple to take your SQL and do something with Python. Because the next cell is about Python and creating a data frame. So I import pandas, and you put that into a data frame. I do some data curation because there were some conflicts on some of the characters, and I convert that into a list. Okay, so now we went from SQL using pandas data frame and having a list. I now want to bring together into one column in the list titles and tags. In the notebooks, you will understand I added some queries to know why I take 1 and 3, because that's title is 1 and tags is column 3 in that list. So I concatenate that. So now we have a list, and that's the list we want to vectorize that has both titles and tags. So probably you install that sentence transformer in the notebook. The next step is to take a library from it, and that's the one we have used, all data set Moneybase. So I hope you are good there. And very simple. Then it's about creating embeddings. In the notebooks, it takes a bit of time to create embeddings on 65,000 rows. Our notebooks are relatively small in compute. So if you go into the notebooks, you will see that I have we have 3,000. So we make sure that we only take 3,000. If you remove that, you will vectorize everything. But that will take longer. It will take 60 minutes instead of 3 minutes. Remember, notebooks are free, so the compute that we use is free behind it. We plan to potentially add stronger compute, bigger compute for that, but give us feedback on that. So then on this example, it's all the rows. And finally, when it's vectorized, we just combine the data here to combine the embedding with the rest of the data. The order is respected. So, like the movie ID will have the same vectors. So now we're good. We have the vectors created, and we just need to bring that back into a single store. So on that one, we use SQL Alchemy and Create Engine. And you see that here again, to simplify the experience between Python and SQL and single store, we create details. So when I select a database, the connection URL will be defined. So I don't need to put all this username, password, everything in the notebook. I can just use connection URL, and that will connect to the database that I selected in the workspace. In the notebook, you see now the creation of a table here, and you see the difference with the other table that has all tags. We have vector. We use format blob. That's how we store the data in the vector data in single store. And then the next is to do an insert command into this table. That's as simple as that. Now the next thing, so we are done. We have the vectors, and we have everything is prepared. We could always improve vector quality, but let's go to the next step. It's about prototyping code and queries. And in this phase 3, there are 3 steps. First is providing full text search capabilities to find titles. So what we did here in the notebooks is, creating that query that's using match against as relevant. So essentially, as you type in your keyboard, in the application, we are going to send requests and try to find the best search match. Essentially, it's not semantic search, it's search relevance based on what you have typed. In hindsight, we should increase from 3 to a bit more title. I think 3 is a bit limited, and we will fix it. But that's the code in the notebook. And below is how it looks on our main.py in VS Code. So very similar. It's and it's very easy to collaborate and prototype in the notebooks and add this code into your VS Code. I mean, I'm using VS Code. You could use other. So that's the first step, is like helping people search and have a good autocomplete experience. The next step is, okay, now that I have my 4 movies, I want to submit my recommendation. So how do we do that? We could create temporary table. Here what we decided to do is create a fake user, like a temporary user. It's almost a user session that we create, and be able to retrieve, and add the title and at what time. That's for more tracking purposes. At what time you added like the title and which titles. And then the next step is, then let's say if you made 3, you picked 3 movies, you will get 3 rows into that table, like called user choice. And the next query is, okay, now it's like the core queries that you are looking at, that has both the filtering and product, dot product, and also the analytics. Let me go over that. So in that query, we pick from user choice the movie selected by that user. And sorry, that movie, and it's based on the user session ID. And every recommendation, even if you are the same user, will create a new user ID. Then the next thing, that's the core. That's really the core. Here it's taking the movies and the vectors of the 3 movies you selected, and doing a cross join with vectorized product with movies with tags, with vectors. So that does a cross join, and essentially the product you will have the 3. If you pick 3 movies, you will have in M1 the 3 movies, and all the movies match. Okay. So this is the core, and that we have multiple functions that we could be used, and Euclidean distance is another one that could be used instead of dot product. So now you have your movies that have been you have your results around matching score. Now we want to a bit curate and only take and rank it in that step. Rank the picked movies, like the movie 2, based on their average. So if you have 3 movies, we'll take the average of the matching score that the movies had. And in hindsight, I do not think there could be a better way actually to add a better than average, had maybe a percentile. So like there is room to improve that than instead of taking average. But that's how we did it on this example. And the last is running really the analytics query and saying, okay, I have those top movies, and I want to join these movies with the ratings and I could, to give a bit more insight as part of a semantic search result, getting some analytics in it. I could have used a filter in the app to say only show movies that have more than 3 in ratings or even more, or only show movies that are horror movies, because guess what? The user only selected horror movies. So, like in this type of queries, you can really do pre-semantic search filtering. Then you do your semantic search, and then you do your analytics and additional re-ranking. And all of that in one database. So now we are in the build front-end code. And so that's a bit like outside in the single store. We had 3 elements: the search box with autocomplete, the recommendation, and the footnotes. That we love full text search and semantic at single store, but also analytics should add. So that's one. Then we had to, that's the front end. We have a main PY file as well. That's very similar to our notebooks, actually. And finally, we have some function built into the front end. So how we build like the autocomplete function over single store. So this is what the code is about here at this point. We have another bonus in this movie, is that the last one. Let me see. It should I need to create the model here. So let me go over the model. That's here. Yeah. So I'm installing. There is a bonus here. It's about, like you write a sentence. It's not in our app, but we will probably have. You write a sentence that we kind of, we create an embedding of that sentence. Like I want to see a French comedy movie. And then, name connection DB, sorry, I should have defined it. It's here, up here. And it will give you, so table movie does not exist. Yeah, okay, I should have started from the beginning, which is not good. I didn't create all the things. I like the concatenate. So that's not good. Never take a notebooks in at the end. Always follow the linear. I hope that it should have worked for you if you do all of that. But essentially, that area, it's something that's not in the app, but it's taking some sentence, vectorizing that sentence, and doing a dot product on that sentence, which is a slightly different mode than picking movies. We could combine both, actually, and that's an evolution of the application. Finally, we deploy on Vercel. We created a GitHub repo that should be public as well for everyone to use. And then we link that repo to Vercel, and it deploys automatically. It really takes just a few minutes. So some takeaways as citizen app developer, and in that space, it's I think I have been a long time in the data space, data engineering space, like data warehouse and data lake. And I think this is really like a new type of data that's actually not new, has been for a long time, but that is going to be broadly adopted. And with that comes the same kind of complexity, like more complexity than as new data types. It's more complex than geospatial. So like when you think about that, there is a whole process about getting unstructured data, tokenize the data in the right shape, right chunks. If you, vectorize the data with the right model, ingest the data, is it real time or is it batch, and validate the accuracy that you have. And frankly, a lot of the job is, you can see that in the notebooks, it's a bit outside. It's about processing the data, refining the data, and and it's an iteration process that's very compute intensive. So when you think about the last one, when you think about building your application, especially if you have a multi-tenant application, you want to have your vectors, and you want to be able to have RBAC and security in mind, with potentially vector isolation, or use in a database row-level security to know to filter out which rows and which vector you want to analyze and show in your application. And notebooks, single store notebooks are great for refining vectors and models. And as we see more and more adoption, we released that in the last 3 weeks. we plan to provide a better, faster experience running those experiments out, and connected to single store. So you can really quickly go and do this back and forth analysis between your database and Python. Last but not least, and it's going back to one of the blog article Eric Hanson and I like we published, is really when you think about like a database, you want something that's holistic, that is that is not separate to just do matching algorithm in number two. You want a way to filter at scale with a lot of tags, a lot of rows, columns, like your information. So for example, I will go back, if in my movie recommendation I see someone hasn't selected some genre, I don't need to do a semantic search against that genre movies, because it's highly likely that if I selected 3 horror movies, I want to watch an horror movie. So you don't need to do semantic search against comedy. Then you have your matching algorithm, so we have a whole documentation around that and a lot of blog posts and even sample notebooks. We even have sample notebooks for doing face matching. You can see the list there. Then enriching your result for better accuracy and insight, and using join, aggregate, and additional filtering for your ranking. The example of only showing movies that have more than 3 out of 5 is a very simple one. Finally, and that's optional, you can communicate that to a LLM model. You can also vectorize your data using OpenAI, but that costs money. That's why you are using sentence transformer, and so you can run the whole scenario. But yeah, and you can communicate. So essentially, what happens here, you send the right context, and the right context is having the best filter analytics to send the most accurate result to OpenAI ChatGPT. All of that, you need to have that done in milliseconds. And we would love to have you try at larger scale single store, vector similarity. I hope you enjoy.
Thank you, Arno, for your presentation. So first of all, apologize. I deeply apologize, and I'm very sorry that everybody faced the blurring issue in the screen sharing. This portion, which was done by Madhukar and Arno, was recorded, and probably that's the reason that we lost some quality at the time of the recording. What I'll do that each one of you who have registered for the today's webinar will be receiving the recording of this webinar, where the resolution is much more higher. You can still follow along, and you'll get all the information regarding how to build an application inside your inbox. So again, apologize for not being able to show you the quality which we generally bring in all our webinars. Now over to Rakesh and Mike. So today we have live Rakesh Puttaswamy with us, Senior Solutions Engineer, and Mike Nguyen. Mike is our Enterprise Solutions Engineer. They are here to take you through how to provision S00 cluster, which was also the requirement for our raffle win. So they will take you through the step-by-step, and you can follow along the process, and you can still be eligible for the raffle. Rakesh, you ready?
Yep. Thanks, Shweta. So I know there's a lot of questions about raffle and a few more things, right? So we decided to give some more time to do that, and I'll walk you through how you can spin up quickly an S00 cluster, right? So just sharing my screen. Can you see my screen?
Yep, on good.
Yeah, all
Rakesh.
good.
Okay, so once you log into this page, right? So once you click on this page, you land in this page, try single store DB cloud for free. So better is you enter last name, first name, or and company address, or you can also sign up with your Google account. Right, so I already have the account. It's a simple process. You just have to sign up with the Google, so you'll receive an email, and then you'll have to use that email to log into your account. So I already have the account, so I'm just going ahead and signing in for the account. So once you sign in, this is the page you get. This is the landing page you get. I also saw some of you are asking about the notebooks, where we can access the notebooks, etc. So once you sign up, once you log in, so this is the page you get it, and you can also see there is a cloud here, right? So the cloud option. There would be a cluster, or there would be a cloud option. So you click on group. So where you create a cluster workspace group. Let's give some name here. Okay. ChatGPT webinar, right? And you choose your cloud provider, right? So I'm just choosing AWS here. Use production version, leave all the defaults, and automatically terminate this workspace after 4 hours. So you can do this. If you don't do this, your credits will burn out. So we are offering you $600 worth of credit to play within single store, right? So I'm just using after 4 hours. You can go ahead and change it, right? So and then click on next. So you can give the workspace name. I'll leave as is. And here you see S00, right? Once you click on edit, you can see multiple compute sizes here. Just go and select S00 here, and then create a workspace. Yeah, that's it. So once you, it will take few minutes to spin up your workspaces. Once you're done, so everything should be in the green and you're good to go. And you can start playing with single store, connecting it and creating the database, and do all the database activities within single store. Thanks for that.
Thanks, Rakesh, for taking us along the provisioning of a 00 cluster on single store. I hope it was easy for us to follow along. If you still have questions, and if you have further questions, or you want to give some feedback and suggestions, you can always write to team@singlestore.com. All of us are present here. We will take your answers and your queries. And if you need any further documentation and information regarding this, you can also reach out to us at team@singlestore.com. So I've just added this email address in the chat. Do take a note, and you can reach out to us directly through this email ID. Now, I know a lot of other questions have also come on today's topic, which is ChatGPT and how to build an application. So I would want to now go to Mike to answer some of those questions. So one of them were very interesting regarding the semantic search. And so there was a question regarding, like, why do we need to do a semantic search? What are the usage and applications of semantic search? This is a very generic question, and it can lead to a lot of applications. So Mike, would you want to elaborate how people can utilize this?
Yeah, so actually semantic search is something is very, very nice. Of course, that earlier we would know about the full text searching, where we will having kind of some word we want to check again. Okay, what are the matching again? Let's say, okay, whether anything matching exactly what. But however, with the semantic searching is just based on the meaning. Let's say mean that, okay, some question like, okay, is husky a dog? Husky a dog. So basically that using the semantic search so that we would be able to know the answer, even though that in our database we don't have exactly the name of the husky. So basically more on the meaning. And then of course that yeah, I think that is a new thing is taking over nowadays over the full text searching capability actually.
Sounds good.
Yeah.
So the next question is regarding, are the notebook and ChatGPT features available on the on-premise deployment also? Rakesh, would you like to answer that?
Yeah, so notebook is not available in self-managed today. So it is available in access through our single store DB cloud. again, it is, you can create your own GenAI app, which are now typically shown in this demonstration, right? And you can integrate your GenAI app along with our single store database tightly coupled to each other, and then you can send that data to OpenAI or other LLMs to process it.
Thanks, Rakesh. The next question, which I don't know who has asked this, it's an anonymous attendee for us, but she or he wants to know, as we limited tokens and the prompt could be long, how do we ensure it's reduced with sentence transformers? So long prompt can be sent and output from GPT can be handled. Mike, would you like to take this question?
So that is very interesting question. So is it more or less about the process? Is kind of mean how you basically how you getting the output, the vector output using the sentence transform for the input. It means the long sentence. So probably there are many ways that you can do. Mean that to get over your problem about the long. So about the prompt could be long. So probably you can using the length change instead of using the sentence transform, just to see me whether it could be resolve your problem. And for single source side, once you receive the vector, so we store it inside one block column. So basically it could be very much long, and then our block column it can be stored the size, the maximum size 2 GB of data. Yeah. Shweta, you on mute? I couldn't hear you.
Always, so sorry. So great, thanks, Mike, for the answer. There is another question on the accuracy level that we predict from AI. We already know it's learning process day to day. So this is also an anonymous attendee who wants to know what is the maximum accuracy level we can predict. I mean, there is no right and wrong answer to it. I know that, but we can attempt to give some idea to this question. Rakesh, over to you.
Yeah, I mean, as Shweta said, it's a more of a generic question, right? So it's how you train your data. How do you want to match your nearest neighbor, or use vectorization or dot product or Euclidean based on your factors? How your GenAI app integrates and what you want as a result is more important in this case. Yeah, that's kind of a more generic answer. I mean, we have a lot of examples and demonstrations which we are going to send you across, and that would give you a better idea when you start developing an app along integrating with the single store.
There has been a lot of questions related to Euclidean search versus the dot product that was shown today. Mike and Rakesh, would you like to take turns in answering, because it's a repeated question that has come up in the chat, and people would really like to know the difference between the two and how they apply these ones.
Okay, so I will go first. So basically that dot product and Euclidean distance basically is using for similar searching. It's just a matter that for dot product you have to normalize the vector value. It means that to the range of under 1, so that it means that if you do the follow the standard format and make it work. And of course that for the result for the dot product, right, it means that the higher closer to 1 is so that it's a higher similarity between the two vector in this case. Yeah.
And also there's a follow-up question for this, right? So do we index vector for an approximate nearest neighbor search, right? Currently we do exact nearest neighbor search within a single store using vector capabilities, using parallel scans and SIMD, single instruction multiple data, to do the dot product and the Euclidean search. That is being very fast and super fast within single store. And also we have done a cool demo using this features, doing the image matching, having a multiple celebrity images and matching against yours, and giving the nearest match. So these are the inbuilt vector features which is available inside single store, and we are constantly working of developing more and more inbuilt vector functions to cater this.
Thanks, Rakesh. There is a very interesting question that is related to the graph database and the vector database. Now, those are current hot topics, and how would you like to address it? The exact question were that how do we compare the graph database with the vector for product recommendation engine? Mike, would you like to go? Sorry, Rakesh, go ahead. Sorry, go ahead first.
Yeah, I'll just quickly brief this, and I'll pass it over to Mike, right? So again, graph, you can do multiple ways. Again, that can also be vectorized. But with single store, you could do a graph queries with recursive common table expressions, which we have inside single store. And then again, this can be, if that is the data is coming through LLMs, it can be tokenized and vectorized and store it. But specific graph-like languages or extensions for single store, we are considering it, and that will be available within the product soon. And also to extend that question, we are also multi-model, right? Along with the relational JSON and geospatial key value time series. These are the first class citizen inside single. So this is not an add-on. So within the product, this sits as a first class citizen within the product. And yeah, so we have a GraphQL, but graph languages and language extensions within a single store would be coming soon, and then you can probably leverage that along with your GenAI and LLMs.
Yeah, so that was great. How say answer, Rakesh? You cover most everything. So basically that how say when we're talking about that for the use case of product recommendation, so of course that you can use in the single store, mean that to do the product recommendation based on the vector value store of that. But of course, more than that, I mean that you also can do the metadata filtering, because before that's one probably that you want to filter down, I mean that, okay, I want to do product recommendation for the people located at certain city, at a certain, mean that, how say certain age. So those things can be achieved with a relational capability of a database like single store. And of course that it can combine with geospatial. For example, you want to locate exactly where they are, also with latitude, longitude, because we do support the geospatial also. So that is not, so saying that mean that single store is a kind of having multiple capability instead of a specialty database like graph database, for example. Yeah.
Thanks, Mike and Rakesh. This last question that I will take, because we're running out of time, as we understand. You can send the rest of the questions to us through team@singlestore.com if you still have questions. But see, this seems to be like a burning question discussed a lot of times regarding the safety and risk of exposing their data to the ChatGPT or AI. And the connected question is that does Squirrel collect our prompt data for research purposes? So these two are related to data safety, and when the AI and chatbot is like really a hot topic right now. So how do you address these two? I'll start with Mike.
Oh, so basically that the how say the security of your confidential of data when you send to mean that any MLM mean that processor. So of course that it's kind of mean that it will rely on those processor, whether they do mean that keep of your personal data or confidential data, mean that to retrain your model for accuracy. So the recent one incident, I mean on the Samsung or the ChatGPT, so they do having that incident. I mean that to keep the data, but luckily nothing related to the how say personal information, or the recent confirmation from OpenAI that mean that they do mean that keep track of the mean that saying whatever the prompt mean that to retrain your model. So that could be something you should consider when using the mean that processor in this. And back to the question, mean that whether our Squirrel mean that from single store side, mean whether we got save any mean that prompt in a single store. So actually that we don't store actually. Yeah, add on. Okay, Rakesh, you want to input something?
No, this looks good. So that's a good summary, I would say.
Okay, thanks, guys. This is that's it. This is as much as the time we had today for our webinar. Thank you so much for everyone who attended to this webinar. To repeat it again, yes, this is being recorded and you will be receiving the recording in your registered email addresses post this webinar. Thanks our panelists and our speakers, Rakesh Puttaswamy and Mike Nguyen. You were very, very generous with us with answering all the questions. And again, if you guys still have some of the questions burning and you want us to address it, please write it to us at team@singastore.com. Thank you so much for joining. Have a great day.